Okay, today we're going to talk about proving triangles congruent. Basically, if you have two triangles, then there's six parts in each triangle that have to be congruent for them to be congruent. Like you've got three angles and three sides, right? Okay, but today we're going to use these little shortcut theorems to show that two triangles are congruent. Okay, side, 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 angle, side, angle, angle, side, and hypotenuse leg. Hypotenuse leg is always used with right triangles. Oops, get off there. Get off there. Okay, so these two triangles are congruent when their corresponding parts are congruent. Okay, this one and this one are kind of shifted a little bit. They're not exactly the same as you would think. They're kind of turned, and I'll show you. Okay, first of all, I would say that side RA, okay, RA is congruent to BO. And I'm just letting you know this. Okay, so on your notes you would say RA is congruent to BO, so those two sides are congruent. Okay, next, which one do you think AT would be matching up with? Well, let me show you. It's AT and OY. I'll put 2 marks for those to show that they're congruent. Okay, so far two sides are congruent. So AT is congruent to OY. These are the sides. And then, of course, RT and YB are congruent as well. So I put 3 marks for those. So far we've shown all three sides congruent in both triangles. Now let's talk about the angles. What is going on? Let me teach. Good grief. Okay, so uh, so angle R would match up with angle B. Do you know why? Because this one is between the 1 mark and the 3 marks. Okay, it's kind of like a road map, kind of helps you to know where it is. This one's 3 and 1 as well, right? So this is where this angle is, B, that matches up to R. So R is congruent to B. Now A, between 1 and 2, would be congruent to O, which is between 1 and 2. Okay, so A is congruent to O, and I just decided to make that a 90. Okay, so we're almost done. We have one more angle. So angle T between 2 and 3 marks is congruent to angle Y. Okay, so I put 3 arcs for that one to show that they're congruent. So here's the 6 parts that all match up to each other. Okay, they're corresponding parts. And since all 6 parts in each triangle are congruent, the two triangles are congruent. And this is what we call a congruent statement. Okay, this is triangle rat is congruent to triangle boy. I don't know why I picked that, but I did. Okay, so it doesn't matter how you do the first 3 letters, but the second 3 letters have to follow. Like R has to match up with B. So because R and B are both congruent. So A, if A is second, then O has to be second. If T is third, then Y has to be third because they match up to each other and they're congruent. Okay? So I could rewrite this and say TAR, right? If I started with TAR, then I would have to do this one all the way backwards too. I would have to say YOB. If I said art, A-R-T, that's the second, first, and third, then I would have to say O-B-Y. Okay, this is not that important, but I need to show you. Okay, so this is, like I said, a congruent statement is a map. Okay, TE, the first two count as a segment. Okay, so TE is congruent to HR, which is the first two in this one. So the first two in each one is a segment that is congruent. The second two, like EX and RN, is a segment that's congruent as well. Okay, and then weird, but outside ones like T and X are a segment as well. H and N are, is a segment. So we got T and X and then H and N. Okay, because there has to be 3 segments, right? And then the angles are easy, right? The first one is equal to the first one. So T is congruent to H. Okay, E is congruent to what? Of course, R, right? So E and R are congruent, and then X is congruent to N. Okay, so that's a congruent statement. It's like a map. Okay, now we're getting into the actual lesson. There's 5 shortcuts to show that two triangles are congruent. Instead of proving that 6 parts in each triangle are congruent, we have these little shortcut theorems like side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. If all 3 sides in 2 different triangles are congruent, then the triangles are congruent. We don't have to show anything about the angles because side, side, side is enough. Okay, side, angle, side. The angle in between is an included angle and shows that the two triangles are congruent. Anyway, it's going to make more sense whenever you see the pictures. Okay, why don't I just do that? Let's move on. Okay, side, side, side. These three sides are congruent, right? And then these three sides are congruent. Now, I know they don't look right, but they should look congruent, but they don't. This came from a book. I don't even know why. But if these three sides are congruent and these three sides are congruent, then these two triangles are congruent by side, side, side. Okay, that's the reason why. Okay, it's like a postulate, whatever. Okay, next, here's a picture of a side, side, side. Okay, so if you have three sides congruent in both triangles, then the two triangles are congruent by side, side, side. Okay, and then you can write this part, but I don't care about this so much. You know, mug, M-U-G, then you would have to start between the 1 and the 3 and then head across the 1 mark. So this is between the 1 and the 3, right? Here and here. And then you have to head toward I, so it's mug him, right? So mug him. So I'm not going to really focus on this. I'm just going to kind of skip over that. But I need you to understand that this is side, 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 and that's why these two triangles are congruent. Okay, next, side, angle, side. There's an angle that's included. They use that terminology, included, which means it's between the two sides that are congruent. So this is side, angle, side. Same as this one, side, angle, side. Okay, so by the reason side, angle, side, or SAS, these two triangles are congruent. Okay, by side, angle, side. You don't have to know about all the other parts that are not marked. Okay, so that's the second one. Let's go to an example. Now, this was a strange example because they're connected. All right. Now, isn't it true that AT, this side right here, is shared by both triangles? Okay. It's shared. Okay. Long time ago, we talked about the reflexive property. Okay. Reflexive means that something is equal to itself. And this is where this comes in. AT is congruent to AT. It is the same size in both triangles. So I only have two parts in each triangle that are congruent, and I want to do side, angle, side. So I have to whoosh, mark this. And this is the reflexive property, and I call it Wolverine, and I make that sound effect all the time. I go whoosh. I know Wolverine has 4 claws, but we'll act like he has 3. Okay, so he whoosh, marked this, and that's what I do with any time that we have a shared side. Okay, so now I can say side, angle, side. And over here, side, angle, side. So these two triangles, bat and cat, are congruent. Okay, by side, angle, side. All right, next, angle, side, angle. This time the side is included between angles. Okay, this is angle, side, angle. With this being an included side, it's included. It's not somewhere else. You know, it's not over here. It's between the two angles. So this is angle, side, angle as well. So by angle, side, angle, these two triangles are congruent. By that reason, ASA. Okay, so here's an example, which is a weird one. I bet you don't remember what arrows stand for. Arrows stand for lines being parallel. Okay, so this line is parallel to this one. This one's parallel to this one. So this could be a parallelogram or a rectangle. Okay, and then it's got, since it has parallel lines, isn't this like a transversal? Remember when we were doing that stuff on the wall outside? We went out there and did, you know, alternate interior angles, alternate exterior. Anyway, so if these lines are parallel, then that angle right there and this angle are congruent by alternate interior angles. Okay, exterior is way out here somewhere. Okay, so the transversal, you're not used to seeing it. Usually you see it sticking way out, but it's not. Okay, so these two are congruent. And then also this one is congruent to this one, right? By alternate interior angles as well. And do we have a shared side? Whoosh, we mark it, okay? We mark it with the Wolverine mark. It's a reflexive side. It's the same size in both triangles. So by angle and then angle, side, angle, these two triangles are congruent, okay? By ASA, all right? So we could say MAD, FDA, but I don't care about that. Let's move on. All right, angle, angle, side. When you have two angles and then some other side, Okay, see the side that's not in between? It's not in between the two angles that are congruent, right? So you got two angles that are next to each other and then some other side. And so this is called angle, angle, side. So this is angle, angle, side. The way people make a mistake is they try to go this way. They try to go angle, side, angle. But that's too far. We're skipping two parts to go that way. We're skipping this side and this angle. This is the way to go, angle, angle, side. Okay? But the way I think of it is there's two angles together with nothing in between, and then some other side, so it's got to be angle, angle, side. Okay? So that's how you spell it, AAS. All right, so do you see the angle, angle, side here? There's the two angles, right, with nothing in between, and then some other side, a non-included side. So this is angle, angle, side. So we'll say car fast. Who cares? Okay? So this is angle, angle, side. Now, hypotenuse leg is only used when you have a right angle. Okay? If you have a right angle, then you have a hypotenuse. Okay? This is the hypotenuse, okay, the diagonal side, or the side better to say this is to say that it's opposite of the right angle. So that's the hypotenuse. And then both of these guys over here are called legs, right? You got two legs in the hypotenuse. Okay? So if the hypotenuse is marked on both sides, and then the leg is marked, then by hypotenuse leg, these two right triangles are congruent, okay? But you have to have a 90 to make sure before you get started. So whenever you start, you say, okay, it's got a 90. I need to check to see if it's HL. Is the hypotenuse marked? Yes, it is. Okay. Is a leg marked? Yes, it is. So hypotenuse leg, they're congruent. Okay. But sometimes the hypotenuse is not marked, and this could be marked, and it could be like side angle side or angle side angle. It could be something different. So you have to check first if it's hypotenuse leg. All right. Car or GTO, who cares? All right. This angle, angle, angle does not prove that two triangles are congruent. You can have a little triangle that has the same angle sizes and a big triangle that have the same angle sizes. Now they're similar, but they're not congruent. Okay, so angle, angle, angle does not prove that two triangles are congruent. So don't write angle, angle, angle. Write not congruent. Because if you write angle, 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 I'm thinking, does he know or she know that these are not congruent triangles? Okay, you know, so say not congruent if it's one of the bad ones. There's two of them. Angle, 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 and then the next one here, SSA, side, side, angle, okay? If you spell it backwards, then it spells a bad word. Can't ever forget it, okay? So SSA does not prove that two triangles are congruent, okay? So that's the other bad one. So you've got an angle, a side, and a side, angle, side, and a side. Okay, so this does not prove it. So if you come across this, you say not congruent. Okay, very good. Okay, so the good ones are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. The bad ones, angle, 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 and side, side, angle. Okay, so here's 6 problems that we're going to do real quick before we go to the 9-problem homework. Okay, and if you're in my class today, you would have gone and did a Kahoot as well, but I'm not going to put that online. Okay, so which one is this? Okay, I've got 3 sides marked, so it must be side, side, side. Yes, very nice. Okay, I don't care about the cat dog thing. Okay, so this is side, side, side. That's the reason these two are congruent. Okay, look at this one. Can I mark it? Is there anything I can mark? Yeah, it's got a shared side. It's got a reflexive side. I can go whoosh and mark it with the Wolverine mark, okay, the 3 marks, and that tells me that this is the same size in both triangles. Okay, so which one is this? Yeah, it's side, angle, side, side, angle, side. Okay, number 3. Okay, don't care about bat, cat. All right, that was side, angle, side. Okay, number 3. Which one is this one? Let me give you a second to look at it. Okay, so I've got 2 angles next to each other without anything in between, and some other side. Which one was that one? Yes, that was angle, angle, side. Okay, angle, angle, side, and then angle, angle, side. You can't go this long way and say angle, side, angle. Can't do that. 2 angles next to each other, nothing in between, and then some other side, angle, angle, side. Okay, what for? I don't care. Okay, number 4. Are these congruent? Yes, they are. By what reason? Okay, this is an angle, that's a side, this is an angle. So, angle, side, angle. Yeah, angle, side, angle. Really, it's simple, okay? So that's angle, side, angle. Okay, look at number 5. Well, I don't care about that. What not? Okay, look at number 5. Now this one's a little harder because you're, not used to seeing something like this, okay? Now this line right here is parallel. Remember the arrows mean parallel. That's parallel to this guy way over here. So I've actually got two transversals. That's a transversal and this is a transversal, so I can have plenty of alternate interior angle situations, okay? So which one is S congruent to? Well, if you said C, you're correct. Those two angles are congruent. They're alternate interior angles. Okay, which one is T congruent to? Yeah, R. Okay, so I can say angle, angle, side. So angle, angle, side works. But isn't there something else I could mark? Do you remember what these angles are right here and right here? If you have intersecting lines and these are opposite angles, what are they called? Vertical angles, that's right. So you can put vertical angles here as well. And this not only is angle, angle, side, but it's angle, side, angle. Okay? Angle, side, angle. So this is angle, side, angle, or angle, angle, side, whichever. Okay, last one. So it's got a right angle. That tells me right away that I need to look at it and ask myself what question. Yes, I have to ask myself, is it hypotenuse leg? Okay? So I ask myself that, and I'll look to see if the hypotenuse is marked, and it is, and the leg is marked. They are. So it's HL. All right? HL. Very good. You're a superstar. Very nice. Okay, so I guess that's it. Time to kill it. Bye. See you later while I try to kill it. Okay, trying to kill it now. Trying to kill it.